First example, use the nodal analysis to find a V1 in the circuit. This is the V1 we are looking for. In nodal analysis, the first step is to define reference node and label nodal voltages. So we're gonna select this node as reference node. Then we define nodal voltage V1 here, and the second nodal voltage V2 over there. The second step to write nodal equations. And the nodal equations are writing based on the KCL, Kirchhoff current law. At node V1, count all the current leaving the node that adds up to 0. So the current in this branch, that is a negative 12. The current in this branch is a V1 over 5. The current in this branch, that is a V1 minus V2 over 5. That is equal to 0. At node V2, we count all the current leaving this node. This branch, that is a V2 minus V1 divided by 5. The current in this branch, that is a V2 over 4. The current in this branch, that is a V2 over 4. We add all the current, that is equal to 0. So step 3 is simply to solve the equations. So we can simplify this equation a little bit. 2V1 minus V2, that is equal to 60. The second equation can be simplified as 7V2 minus 2V1, that is equal to 0. Now we can find V1 is equal to 35 volts, and V2, that is 10 volts. Step 4 is to write the conclusion. What we are looking for in this problem, that is V1. So V1, that is equal to 35 volts. If we look at this problem again, we notice that this problem only have a independent current source. So it also implies that we can do model by inspection. So the second method, so since we defined two nodal voltages, it implies that we have two equations, and it has a form of a 2 by 2 matrix times unknown variable V1 and V2, and on the right hand side are simply the current goes into node V1 and V2. So the current goes into node V1, there is a 12 milliamp. There's no current source goes into node V2, so we have 0. In the 2 by 2 matrix, the diagonal entities are the summation of the conductance connected to the node. So for node V1, we have 1 over 5 plus 1 over 5. For node V2, we have 1 over 5 plus 1 over 4 plus another 1 over 4. And the off-diagonal entities are the shared conductance between the nodes with a negative sign. So for this entity over here, that is a shared resistance of 5 kilo ohm, so we have a negative 1 over 5. And since the matrix is symmetric, we also have a negative 1 over 5 here. You can solve the equation for V1 and V2. You will find the same answer, 5 volts, and a V2 that is 10 volts. Then you can write your conclusion. Say V1 that is equal to 35 volts.